We've got someone's age 25 and we add 1. Looks fine. But those quotes are about to ruin our day. Predict what happens before I run it. A type error. Python can only glue text to text, and we tried to add a number to text. Those quotes made 25 a string, not a number. This hits every beginner. The fix is one small function. Type conversion, turning one type into another. Why did it fail? Every value carries a type, and the type decides what you can do with it. 25 in quotes is a string, text a 2, then a 5. 25 with no quotes is an integer, a real number you can do math with. Str, a string, that's the text version. Int, a real integer. To Python, these are as different as the word 5 and the number 5. So here's the fix. The int function takes a string and hands back the number it represents. Feed it the string 25, and you get the integer 25, a real number you can do math with. Think of it as int reading the text and understanding it as a quantity. The characters 2 and 5 become the actual value 25. Let's rescue the broken program. We convert age with int, storing the real number back into the same variable. Now age plus 1 actually adds no error, because age is finally a number. "26, the addition works now. And the type is int. One call to int, and the crash is gone. It goes the other way too. Say you want a number inside a sentence. You can't glue a number straight onto text. Same type error, reversed, so we wrap it in str, turning 90 into text. Now it's text joining text. You scored 90 points. Later, F strings do this joining more cleanly, but str shows you what's happening underneath. Conversion isn't just numbers and text. A quick callback to the Booleans episode. Remember, true is secretly 1 and false is 0. Int makes that official. And bool goes the other way. 0 is empty, so bool of 0 is false. Int of true is 1. Int of false is 0. Bool of 0 is false, empty. And bool of real text is true. Now the surprise everyone hits. Decimals need float, and int has one surprising behavior. Float converts text to a decimal, 9.99, for anything with a fractional part. But int on a decimal chops it. 3.9 becomes 3, not 4. If you want the nearest whole number, that's round, which gives 4. Float gives the decimal, 9.99. Int chops towards 0. 3.9 becomes 3. Round finds the nearest. 3.9 becomes 4. What if the text isn't a number? We ask int to turn the word hello into a number. There's no number in there. Predict it. A value error. The value just isn't convertible. Notice it's a value error this time, not a type error. The type was fine. It's a string, but the value inside couldn't be read as a number. That distinction matters. Type error means wrong kind of thing. Value error means right kind, but bad content. Real users type nonsense into your programs all the time, and int will happily crash on it. Handling that gracefully is a job for try and accept, which we'll get to down the line. Here's where this bites you. Every time you read what a user types, Python gives it as a string. Always, even if they typed a number. So if you add 2 numbers without converting, you don't get 10. You get the text 7 glued to the text 3. Watch the difference one conversion makes. Two strings added just stick together. Convert each with int first, and now it's real addition. Seven 3. The plus glued 2 strings together. Convert first, and the plus adds real numbers. 10. Every value has a type, and Python won't mix text and numbers on its own. Use un-des for whole numbers, float for decimals, and str to turn numbers back into text. Remember the 2 traps. Int chops instead of rounding, so reach for round when you want the nearest value. And int throws a value error when the text isn't actually a number. Everything here comes down to one habit. Check what type you're holding and convert it before you combine it. The next skill depends entirely on this. Take the string 9.5, convert it with int, and predict the result. Remember, int chops. Next, all the little symbols that do the work. Math, plus sneaky ones like modulo that unlock real tricks.